Hello, in this session we are going to talk about trigonometry. Trigonometry is about triangles. It's about calculating the sides and the angles of a triangle. Now, let's start by looking at a very simple example to develop the ideas. We start with a right-angled triangle that looks like that. Now, suppose that the length of this longest side is 2 centimeters and the length of this shorter side is 1 centimeter. Right? Now, and this angle here would actually be 30 degrees. So let's start with that. If you're given this triangle, now suppose that we have another triangle that is similar but bigger. Okay, a bigger triangle that has the same angle, 30 degrees down there, but a longer side of say 4 centimeters. And suppose that we have to find the length of this side. I'll call that x. We can actually do that because we have learned about similar triangles. So in these two triangles we have the angles all equal. Right, that's 30 degrees, that's 90 degrees, 30, 90. So the remaining must be 60 and 60. So when all the angles are equal, the two triangles are similar. And that means that the ratio of corresponding sides must be equal. So we can say, for example, that if I divide this side by that side, right, so 1/2, we divide this side by this side. Now the corresponding sides would be that and that. So if I divide x by 4, it should be equal to half. Right, the ratios of those two sides must be the same as those two. So if we know that this x over 4 is equal to half, we can calculate x. We can easily find that x is actually equal to 2. Right? So this is a simple example in which if we know the sides of one triangle, we can actually find the sides of the other triangle. Now the idea here is that if I have a different angle, I would have a different triangle and a different side. But if I know that the ratio between these two sides when the angle is 30 degrees is half, I can use this result to find the length of the sides of a bigger triangle as long as the angles are the same. So this is the idea that goes behind trigonometry. So the idea is that if we make a table or if we have a calculator that can always tell us what this ratio is, then we can always use that to help us to find the length of the sides of a triangle that has a different size, that has any size. And in fact, this ratio of 1/2, this fraction of 1/2 is called sine 30 degrees. Right, so now we're going to move on to see how we can use this idea in trigonometry. So in trigonometry, we have to define a few we have to define something which is called a sine of an angle. Sine. Now what does the sine of an angle mean? If this is what it means, we have to look at a right-angled triangle like that. Now to start off with, let's learn the names of the parts of a right-angled triangle. If I start with this angle here, okay, which I call the angle A. Now, let me call this side Y, and call that side X, and call that side R. So I'm using symbols to represent the lengths of the sides. But for a right-angled triangle, there are special names for the sides. Now, if I refer to one of this angle, A, then the side that is next to that angle has a name. It's called adjacent. ADJACENT. And the side that is opposite the angle is called opposite. And the longest side is called a hypotenuse. That's spelled HYPOTENUS. No E. Right? Now what do we mean by the sine of an angle? Now if we are talking about this angle, then we say that the sine of the angle A is equal to this side, the side opposite the angle, divided by the longest side. Alright? Now, if you are seeing this for the first time, you will wonder why we bother to make up something so strange like that. A right-angled triangle is just a right-angled triangle. Why do we want to make up all these names and all these abstract fractions and equations? Now you have to bear with me, because I will explain eventually, after a while, how we can actually use this to calculate the size of a triangle. So for now, we are just going to learn the names of the parts of a right-angled triangle, and we are going to learn the meaning of this thing called sine, S-I-N-E. And we also have to learn some symbols. Now the sine of an angle A, as I said, is given this meaning, alright, that it is equal to the opposite over the hypotenuse. Now what does that really mean? It means that if I have a certain angle of so many degrees, then the sine of the angle is equal to the length of this side divided by the length of that side. So before I give some example, I will write down a symbol for sine of an angle. The symbol is S-I-N-A. So that's the symbol for sine of an angle. If I use the symbols for opposite and hypotenuse, then these are Y and R. There is actually an E at the end of hypotenuse. I shouldn't have taken that out. It's hypotenuse spelled with an E at the end. So sine A will be equal to Y over R. Okay, so we start by learning the meaning of this symbol. Sine, S-I-N-A, is equal to Y over R. So let's just look at some example of what this means if we start putting in some numbers into the angle and the sides. Now suppose I have this triangle where the angle is 30 degrees, that's a right angle, and that's 1 cm, and the hypotenuse is 2 cm. So if I want to think about the sine of that angle, that would be sine 30 degrees. That's how I would write it. And that should be equal to the opposite over the hypotenuse. That is 1 over 2. So that's sine of 30 degrees. Right. So sine of 30 degrees is equal to half. But what if I have a bigger triangle with the same angles, like that? Right angle, 30 degrees, but this time this is 4 centimeters, this is 2 centimeters. So what is the sine of 30 degrees this time? Let's check. Sine of 30 degrees is 2 divided by 4. And you will find that the answer is exactly the same. 2 over 4 is the same as half. And the reason is quite simple. Because all the angles are the same, these two are similar triangles. Therefore, the ratios of the sides must be equal. So we have found something special about the sine of an angle. Alright? The sine of an angle is the same for the same angle whether you have a smaller triangle or a bigger triangle. And that's one of the things that is going to make this idea useful, because the sine of the same angle is always the same. So we'll see how it's useful very soon. But we are going to do the next thing in trigonometry. Now we've learned about sine. Now we are going to learn about another thing called a cosine. Right. Cosine is spelled C-O-S-I-N-E, the cosine of an angle. What does that mean? We are going to refer to use the same angle A again. So if I say the cosine of angle A, what it means is the side adjacent to A. That side adjacent divided by the longest side, the hypotenuse. So that's the meaning of cosine, this thing called cosine. And we use the symbol COS as a short form for cosine, A for the angle, or the angle can be a different symbol. I could have called the angle B or any other letter, but the short form for cosine, symbol for cosine must always be COS. Right, so this is equal to x over r, adjacent over hypotenuse. Okay, so that's the meaning of cosine A. So in the same way, let's look at some numbers to see how you can actually calculate this cosine thing. Now suppose I have this right-angled triangle, and we look at the angle of 60 degrees there. So this side, longer side is 2, the adjacent side is 1. So for this triangle, the cosine of this 60 degrees angle is written as COS 60 degrees. So this is a symbol for cosine of 60 degrees. The adjacent over hypotenuse is 1 over 2. Alright? So for this triangle, cosine 60 degrees is equal to half. So we have an example. We have an example with this number here. Right? What if we have a bigger triangle where the longer side is 4, the adjacent is 2. Now you can see what's going to happen. In this case, cosine of this angle is again adjacent over longer side, 2 over 4. And you will find that the answer 2 over 4 is really equal to half. Alright? And the reason is simply because the two triangles are similar. If all the angles are the same, Therefore, the ratios of the sides must be the same. So once again, we see that for the cosine of an angle, it does not depend on the size of the triangle. Okay. And the last thing we're going to learn here is something called a tangent. The tangent of an angle. Now in this case, again, we look at the angle A. So the tangent of the angle A is equal to the side opposite the angle divided by the side adjacent to the angle. Opposite over adjacent. And the symbol for tangent is tan. Tan of the angle A is equal to y over x. That's the symbol. So let's have a look at an example again to see if it behaves like the sine and the cosine. Let's look at this example where this is 45 degrees and this side is 1 and this side is 1. A simple right-angled triangle. Right? Now if I want to find the tangent of that angle, we write tan 45 degrees. In this case, it is the opposite over adjacent, 1 over 1. The answer is just equal to 1. Now what if, again, we have a bigger triangle? Bigger triangle, the same angles, but the side here is say 2 and 2. Okay, then tangent of 45 degrees is equal to 2 over 2. And once again, because these are similar triangles, they have the same angles, ratios of the corresponding sides must be equal. And that's why we have 2 over 2 equal to 1 over 1. So this means that the tangent of an angle does not depend on the size of the triangle. So far we have learned 3 things about trigonometry: the sine, cosine, and the tangent. Alright, let's now look at some examples to see how we can actually use these. Let's look at this example. We have here a triangle. There's a right angle in the triangle. We're given that one of the angles is 20 degrees, that the length of this longest side is 5 centimeter, and the question is to find x. What is the length of this side that is opposite to the angle? Okay, so let's see how we can apply the idea of sine to do this question. Okay, we start with turning this triangle around into a more familiar position that we have seen just now when we learned about sine. I'm just going to turn it around, okay, so that just, rotate it this way until it looks like this. Right, so the x comes here, the 5 cm goes there, and the 20 degrees go here. Okay, so I simply rotated it. So that's a bit more familiar, and if we remember the meaning of sine of an angle, sine of 20 degrees in this case is equal to the opposite side, which is x, divided by hypotenuse 5. So this is the relation between sine of this angle and the unknown x that we have to find. So if we somehow know the value of sine 20 degrees, we would be able to find x from this equation. So that's the problem here. How do we know the value of sine 20 degrees? Now, a long time ago, alright, maybe 100 years ago or more, in order to find the value of sine 20 degrees, people use a rather simple idea. You can use a protractor and draw and measure out the angle of 20 degrees, right? And then draw a right-angled triangle of a certain size. Now it does not matter what size this is, because we have seen just now that whether the triangle is bigger or smaller, the sine of 20 degrees, which you can find when you take this divided by this side divided by that side, will always give you the same answer. Okay, because as long as that's 20 degrees and that's a right angle, a bigger triangle will be similar to a smaller triangle. So you can just draw a triangle of any size and with one of the angle 20 degrees and use a ruler to measure the opposite and the hypotenuse and divide them to give you the sine of 20 degrees. So that's one, if you like, a simple, straightforward way to find a number for 20 degrees. Just with a ruler, a protractor and a pencil, right? Now, but today, all these values can be calculated on a calculator. If you like, mathematicians have developed ways to calculate this answer very accurately without having actually to draw a picture and measure it. That's not very accurate. So we can actually find this number of sine 20 degrees from a calculator. Right, let's see if you can see the numbers on the calculator. See that, right? Now I'm going to find sine of 20 degrees. So I start by pressing sine and then 20. I close the bracket there and I press equal. That's the answer. 0.3420 and so on. Let's write that down. So this is 0.3420. That's sine 20 degrees. So we have found the value very easily from our calculator. So once we know that x over 5 is 0.3420, we can easily find x. We know in algebra that you can get x if you multiply both sides by 5. Alright, and then you can use your calculator to find the answer, which is 1.710. That's the answer. So x is 1.710 centimeter. And that's the length of that side. So we have just seen how we can use sine to help us to find the sides of a triangle. And it's very useful. Okay. Now you might think that I've just been talking about right-angled triangle, and it's not very useful if I can only use this method for right-angled triangle, because after all there are many triangles that are not right-angled. And you're right. In fact, trigonometry can also be used for more complicated triangles. But in this topic, we tend to look at simpler triangles for a start. But as an example, let me look at an isosceles triangle. Right. Suppose that this side is equal to 10 centimeters and this side is equal to 8 centimeters. So those two sides are equal. Alright, so that's not the right angled triangle. The question is, find this angle, which I call theta. So this letter here, this strange symbol here, is a Greek letter, which is called theta. Just write that here. Theta. And it's often used as a symbol to represent an angle. So we don't have a right angled triangle this time. How are we going to use our sines and cosines to find this answer? Right, so we have to talk about the technique that is used when we learn about trigonometry. And usually in trigonometry, if we have a triangle that is not a right angled triangle, then the way is to divide this triangle up into smaller triangles that have right angles. Now in this case, for example, I can draw a vertical line to the base, right, meeting the base at a right angle, and I know that because this is isosceles, this vertical line will go to the center of the base. It will divide the base into two equal halves. Since I know that the base is 8 centimeters, each half would be 4 centimeters. Now once I do that, I can look at just one of these triangle. This half of this triangle is actually a right angled triangle because that's 90 degrees. So now we have our right angled triangle, and then we can try and use the sine and cosine. If I look at the one on the left, for example, okay, this is our right angled triangle and this is the angle that we have. Now to make this more obvious, I'm going to draw this triangle out again, just to make it quite clear. So it's this triangle, that one there, that's a right angle there, this is theta, that's 10 centimeters, and this side is half of 8 cm, that's 4 cm. Okay, so we're going to concentrate on this right angle triangle. And if you look at this, you see that we have this angle, this unknown angle theta. The adjacent side is the 4 cm and 10 cm is the hypotenuse. Now in this case, we would use the cosine. So cosine of this angle is equal to the adjacent 4 divided by 10, the hypotenuse. So how can we find theta from this equation? Well, a long time ago, before they have invented the calculator and before they have invented so much mathematics, we can do it quite simply by constructing that triangle. Just take out your ruler and protractor draw a 4 centimeter line, construct or measure out a 90-degree angle and draw a vertical line. Okay, and then take out your compass and adjust it to a length of 10 cm and simply mark out a point on the vertical line and draw a straight line joining the two corners. So once you construct this triangle by your ruler, compass, protractor, you can then take out your protractor and measure that angle. Alright, so as long as you know that the cosine is 4/10, you can always draw that triangle. So that's simple enough. We know that it can be done. At least that's one way to do it. But again, because today people have invented the calculator, we can use the calculator to find this answer. Now, we need to do something slightly different from before. If you remember, just now, I found the sine of an angle where I know what the angle was. So I find the sine of that angle using the calculator. Now this time, I do not know what the sine of the angle is, but I know the answer. I know that the answer is 4/10, which is 0.4. So I know that the cosine of the angle is 0.4 and I want to find the angle now. I don't know what the angle is. So I'm doing the opposite. How do I do that? Right, now if you look at your calculator, you will find a button that says COS. So that was the SIN which I used just now. That's the COS. So COS is the cosine. But if I want to find the angle, now if you look above the cosine, you will see some tiny words above the cosine which shows COS with a -1 next to it. Alright, just above the cosine button. You see COS with a -1, usually hopefully in your calculator as well. Now the -1 up there means inverse. So in this case it means that it will allow you to find the angle. Now but the COS -1 is not a button, you can't press it, but you would select it by using the shift button. Right, if you can find it on your calculator, you would press shift and then press cos. So that gives you the cosine -1 symbol. And then I know that the cosine is 0.4. Right, they found that it's 0.4 there. So I would do this cosine -1 of 0.4. I'll close the bracket and press equal. And the answer is 66.42 degrees. So I say that theta is, I would write this as cos minus of 0.4, and the answer is 66.42 degrees. So then we have our angle, 66.42 degrees. So we have learned a new symbol here. It's related to cosine, but it has this -1 up there, and this is called inverse cosine. The -1 stands for inverse. So we're using it to find the angle. Now we have to be careful when we write or see this notation, not to confuse this inverse with the power of a number. So for example, if I have a number where I say 2 to the power of minus 1, then we have learned previously that this means 1 over 2. So that's also an inverse, but it's this kind of inverse, just simple 1 over that number. Now we have to be careful here. The minus 1 there is more abstract than the minus 1 here. The minus 1 there does not mean 1 over the cosine like that. Alright, definitely does not mean that. The minus 1 there simply means that it gives us the angle of the cosine. Alright, so in that sense it's an inverse of the cosine that we start with. Okay. So let's look at one last example before we finish off. Suppose we have this figure. Two of the angles are right angles. That angle is given as, say, 70 degrees. That length is 5 cm. That length is 3 cm. Okay, and the question is to find this side. So that's the question. So now we have a slightly more complicated example. Let's see how we can use the sine, cosine and tangent to find the answer. Now, as I've said in the last example, in order to use these ideas, we would have to try and divide the figure into right-angled triangles. How can we do that here? Right, I can do this. Draw a vertical line here. So that's 90 degrees. Now this gives me that triangle, which is right-angled. That's a right angle. Now let's see if this helps. If I look at this triangle, I can see that this side is the same as the x. Okay, so that's x. I can also see that this side can be calculated because this is 5 centimeter, but from there to there it is 3 centimeters. So therefore, this side, alright, from here to here is 2 centimeters. So we have learned quite a few things about this triangle there. So can we now use sine or cosine to find x? So it's always useful, makes things easier, alright, until you are more experienced in this topic, to rotate this triangle so that it looks the same way as the triangle when we learn about sines and cosine. So I'm just going to flip this over. Okay, so sort of flip it around that way so that this side comes down here. So the 2 cm is now here. That's our right angle. That's the 70 degrees. That's the x there. So that's our right angled triangle. So what we have here is we have an angle, we have the side adjacent to the angle, and we want to find the side opposite to the angle. So angle, adjacent, opposite. So this is tangent. We need to use the tangent of an angle, because tangent of this angle, 70 degrees, is equal to the adjacent over, is equal to the opposite divided by the adjacent, x over 2. So you can see that we should be able to use the calculator like before to find the answer. Now before pressing the calculator, let me rearrange this. Okay, if I multiply both sides by 2, the 2 there and the 2 there cancels. So I have x equals to 2 times tangent 70 degrees. Let me write this out. X equals to 2 I've left out the times because I can treat this as algebra. So 2 tangent 70 degrees means 2 times tangent 70 degrees. Now it is often useful to do this rearranging to make x the subject before we use the calculator, because then all the numbers that we have to calculate are on one side, so we can calculate the whole lot all at one shot, rather than calculating something on the right and something on the left and then rearranging that and then doing more calculations. Alright, this would also reduce the rounding off errors. Okay. So let's have our calculator again. Now this time we need to use the tangent, which is there. Okay, we need to do 2 times the tangent of, right, that was 70 degrees, so 70 close bracket equals 5.495. Right, so the answer 5.495. So that's the length of x. X is there. 5.495 cm. So that's it for this session. Thank you. See you next time.